welcome to my demonstration on how to make citrus batteries. Today we're going to be doing an experiment that demonstrates to younger children how a circuit works and how to create electricity and light up a light bulb. So, when life gives you lemons, what do? You generate electricity. So first we're going to start off with various amounts of lemons. Some more materials that you're going to need for this experiment are copper nails, zinc nails, wires with gator clips, an LED light, preferably red, a multimeter to check your voltage, and maybe a battery to demonstrate to kids how to light up an LED. So first we'll start with that. We have just a simple LED and a battery. This battery is 3 volts. So this basically just shows how to complete a circuit and light up a light, and then we're going to also be doing the same thing using lemons. So lemons are an everyday object that kids can really grasp and feel, and they can put this together themselves because it's fairly easy. Instead of using copper nails, if you wanted to use pennies, you could do that as well. So the way this experiment works is you set up your lemons in series, so you set them up next to each other, and then in each lemon you insert a zinc and a copper nail. Now these nails should be about 2 centimeters apart. That's a pretty good distance for the experiment to work. So your amount of lemons can vary. You can have anywhere between, say, maybe like 4 to 10 lemons. Right now I'm using 1, 2, 3, 4, 5, 6, 7, 8, 9 lemons. So that's another way you can change up the experiment. You can also change it up by using different fruits, such as oranges or grapefruits, basically anything with citric acid inside of it. So in order to create a battery, you're going to need 3 things. You're going to need 2 electrodes and 1 electrolyte. In this experiment, our electrodes are going to be our nails, which are zinc and copper, and our electrolyte is the lemon. So a common misconception is that the lemons are the electricity. Now, that's not true. What really happens inside this lemon is you insert your zinc nail and your copper nail. The zinc does not have a tendency to want electrons as much as copper does, so that's a good discussion on electronegativity. The copper wants the electrons more, so all the electrons from the zinc material are going to want to go towards this copper material, and that's because when you insert zinc in an electrolyte, zinc ions are going to start to form. Now this leaves you with an excess of electrons. So the electrons are going to move through your electrolyte material, and they're going to go through the copper nail and your external wire to the zinc nail of the next lemon. And in the next lemon, the same thing is going to happen. The zinc is going to ionize within the lemon, and the electrons are going to move through the lemon into the copper nail and out through the wire. And this is what brings those electrons to your light bulb. In this case, we're going to be using LEDs. LEDs can be used to talk about smart lighting concepts such as efficiency. So that's another good discussion to have when doing this experiment. One problem that comes up with this experiment is this formula right here. Voltage equals current times resistivity. So within these lemons, they have enough current and enough voltage to light up an LED, but the resistivity is what really kind of drags this experiment down in a way. So as you can see, when you have a 3-volt battery and an LED, you can light up this LED pretty bright. That's because the resistivity is not very high in this case. But when you make a circuit out of all of these lemons and wires, your resistivity is kind of high. So the brightness of the bulb that it makes is not very high. So we can see the brightness if we move closer. Sometimes it's helpful to have a little box to put your LED in so you can really see it lighting up. So if you see in there, we do have a light coming from this lemon circuit. Thanks for watching.